Hello everyone and welcome back to these sessions on quantitative methods for CFA level 1. Now we were in the topic time value of money. We are dealing with the basics of time value of money, and mind it, at a little later stage we are going to go deeper into the time value of money in finance, which will be a little advanced level, but here we are just clearing the grounds. In today's class, under time value of money, we are going to learn something about effective annual rate. Now this has everything to do with the compounding of interest. So you have noticed one thing, how compounding impacts your future value, correct? So suppose you go and borrow money and the lender is demanding the settlement of interest on quarterly basis. So the lender has stated the rate of interest as 12% per annum. I repeat that line. The lender has stated the rate of interest as 12% per annum, but the lender puts a condition that the lender will charge interest at end of each quarter. That means the settlement of interest has to be made at end of each quarter. So how would you compute interest? Simple logic. A year comprises of 12 months and the stated interest rate is 12% per annum. So if you want to find the monthly interest, you divide 12% by 12 months. But here the frequency of interest payment is not monthly. What I have just placed as an example, in this example, the frequency of interest payment is quarterly. I am coming to our current example anyway, but what I want you people to understand is, if interest is stated as 12% per annum, it will be basically treated as 1% per month, because 12% divided by 12 months, 1% per month. Now a quarter comprises of 3 months. So for a 3-month period, the stated interest rate will be 3%. We call that as periodic interest. So interest for that period will be 3%. Alternatively, I would say the stated interest rate being 12% per annum, in a year how many quarters exist? So there are 4 quarters in a year. So you divide 12% by 4 quarters, the periodic interest will again be 12 by 4, that will be 3%. Now what happens? What is the impact of compounding and the frequency of compounding? Now see what will happen. Suppose the amount that you have borrowed is $1,000 and the rate of interest is 12% per annum, and interest has to be settled once every year. Then without using calculator, you can work it out. $1,000 into 12%, annual interest will be $120. Matter over. I don't have calculator in my hand, neither you need to make that calculation. You can do that mental math and apply. $120 is your interest. But if you go for the interest settlement on quarterly basis, what will happen? You have borrowed same amount, $1,000. Interest rate stated by the lender is also the same, 12% per annum. But now the lender has put a condition that interest has to be settled every quarter. So what will happen? Let us assume that you don't pay interest every quarter, but the interest accrual will happen at end of each quarter. In other words, the lender will add the periodic interest on the principal balance and compounding begins thereafter. So let me get back to one simple thing, that is, if the stated interest rate is 12% per annum, you find that there are 4 quarters in a year and interest in this example has to be settled every quarter. So what will be the periodic interest rate for each quarter? It will be 12% divided by 4 quarters. That will be 3% for each quarter. Now, on $1,000 that you have borrowed, the lender will charge interest for 3 months, and that will be 3%. 3% of $1,000 will be what? $30. Now, you did not pay interest immediately because your plan is to pay interest only at end of the year. Fine. But what the lender will do? Lender will compute $30 as interest for that first quarter and add it to the principal balance. In the next quarter, again 3% interest as periodic interest will be charged, but not on $1,000 of the original principal, on the revised balance of the principal, which is now having accrual of interest of 3 months. So the cumulative balance now is $1,030, $1030. On that, 3% interest will be charged. That means you pay interest on interest. So there is compounding of interest happening within a year. So by the time you end up or you reach the end of the year, effectively you would have paid a little more interest compared to 12%. So here we have to find out that if the stated annual rate SAR is 12%, but the frequency of interest settlement is quarterly, then the effective annual rate will not be 12% per annum, will be little higher, because within a year 4 times interest settlement is planned. Compounding of interest starts happening within a year as well. All the earlier calculations what we have learned under time value of money, compounding of interest had been happening on yearly basis because it was all annual compounding. So if within the year the compounding happens for a shorter periods, in other words, the frequency of compounding within a year is multiple number of times, monthly, quarterly, semi-annually, of course the effective interest rate or the effective annual rate by end of the year when you compute, it will be something more than the stated annual rate. So simple thing is, effective annual rate will be equal to the stated annual rate if the compounding frequency is only once a year. But the moment you increase the compounding frequency beyond one time within a year, suppose it is semi-annual, so there will be 2 times interest settlement happening within a year. So interest gets compounded semi-annually. If it is quarterly frequency, interest gets compounded quarterly. If it is monthly frequency, interest gets compounded monthly. Now, the higher the frequency of compounding, the higher will be the effective annual rate as against the stated annual rate. So what would be your objective in this entire series of calculation? If you have been given a stated interest rate or stated annual rate along with the frequency of compounding, your objective is to work out the effective annual rate. Sometimes it may have a reverse calculation effect, that effective interest rate or effective annual rate is given to you, frequency of compounding is given to you, and you have to specify what will be the stated annual rate. So let us do one thing. In this class, we are going to again take up lots of calculative examples to understand the concept, but initially let us focus on writing some important notes. So under the heading effective annual rate, you please write concept of effective annual rate. Financial institutions usually quote rates as stated annual interest rates along with a compounding frequency, as opposed to quoting rates as periodic rates, that is the rate of interest earned over a single compounding period. For example, a bank will quote a savings rate as 4% compounded quarterly rather than 1% per quarter. The rate of interest that investors actually realize as a result of compounding is known as the effective annual rate, that is EAR, or effective annual yield, that is EAY. Let us move ahead and continue writing further. EAR, that is effective annual rate, represents the annual rate of return actually being earned after adjustments have been made for different compounding periods. EAR may be determined as follows. EAR equals to 1 plus periodic rate raised to m minus 1, where periodic rate equals to stated annual rate divided by m, and m equals to number of compounding periods per year. Let me explain this particular aspect of calculation to you. See, some time back I gave you an example that the stated annual rate is 12% per annum and the frequency of compounding is quarterly. Means in a year 4 times the interest will be computed and adjusted. So what we identify? We identify a variable m which will be indicating the frequency of compounding within a year. So in our example, if the quarterly compounding is mentioned, means the frequency of compounding will be 4 times in a year. So what we did to compute the periodic rate, we have divided the stated annual rate by 4. 4 is that variable m in our example. So what happens? Because it is going to get compounded 4 times in a year, so for 1 year what we do is we take 1 plus the periodic return. And what is the periodic return? It is the stated annual rate divided by m. That whole thing will be raised to m, so that you get the compounding effect in terms of number of times within a year. And then because we started with a factor, to find the pure interest rate we have to subtract 1 at the end. So if it is 12% per annum as stated interest rate and you want to apply quarterly compounding, so it will be 1 plus, within the fraction it will be 12 by 4, so that will be 3%. So 3% will be 0.03. So 1 plus 0.03 raised to 4, and whatever be the factor that results out of that, from that you subtract 1, and whatever you get, that will be your final answer as effective annual rate. Now let us move ahead and write something more about effective annual rate. So please continue writing. Obviously the EAR for a stated rate of 8% compounded annually is not the same as EAR for 8% compounded semi-annually or quarterly. Indeed, whenever compound interest is being used, the stated rate and annual effective rate of interest are equal only when interest is compounded annually. So you should notice this point very well, that the stated rate and effective annual rate will be same only and only when the frequency of compounding is only once in a year. I have explained this to you earlier as well. Otherwise, the greater the compounding frequency, the greater the EAR will be in comparison to the stated rate. The computation of EAR is necessary when comparing investments that have different compounding periods. It allows for an apples to apples rate comparison. Let us move ahead and take up the next example to understand this whole thing. Example 23. Let us observe what is given over here. Principal amount is given as $1,000. Rate of interest is 21.9% per annum. So when it is given like this, this is what we call as stated interest rate. Calculate the amount receivable at the end of second year if interest is compounded annually, if interest is compounded half yearly, if interest is compounded quarterly, monthly, daily, and at the end they have mentioned if interest is compounded continuously. So what we identify in this example, that the frequency of compounding in each of these 6 cases, it is varying. and most important thing, it is not just 1 year of the time period given to you, it is 2 years time period given to you. So basically if it is annual compounding, you don't have to apply any adjustment. What you need to do is, because it is a 2-year factor, it will be 1 plus I raised to 2, correct? 1 plus I raised to 2. I over here will be the stated interest rate, which is what? 21.9%. So it will be 1 plus 0.219 raised to 2. That will be the factor multiplied to $1,000 will give you the maturity value or future value at the end of second year. But what happens when the interest is compounded half yearly, or we can also call it semi-annually? Now this is the most important aspect, because when we start dealing with fixed income, that is all the content relating to bond and bond valuation, generally you will come to know that US Treasury bonds, they have a default period of coupon payments as semi-annual. As a result, your expectation as an investor is not for getting the entire year interest. Your expectation itself is semi-annual returns. As a result, your effective interest rate or effective annual rate will be based on semi-annual compounding. In other words, if the frequency of receiving coupon payments from those bonds is going to be once in every 6 months or once in every half year, that is semi-annually, your expected rate of return also becomes semi-annual. So both things, your coupon rate as well as your expected rate of return, should be adjusted for that semi-annual payments, and accordingly the valuation of bonds will be carried out. Anyway, right now we don't have to do that, but what I am telling you is, understanding the frequency of compounding is very, very important throughout your curriculum. So what will you do if it is half yearly compounding or semi-annual compounding? You will be taking simply the stated interest rate as 21.9%. Because it is half yearly compounding, means compounding will happen twice in a year. So the first effect that you have to give is the effect on the interest rate. The stated interest rate will be divided by 2, because that will be the rate for the half year, which we call as periodic rate. So if 21.9% is the annual rate, 21.9 divided by 2, that whole thing expressed as a percentage will be the periodic rate for 6 months. So 1 plus that periodic rate raised to 2 times 2. Why I am saying 2 times 2? Because 2 times is because of m being 2. M being 2 as in your frequency of compounding within the year is 2 times, and on top of that the total period is 2 years. So it will be in total 4 times compounding happening within 2 years. So that will be 2 into 2, that will be 4. And likewise you keep on doing the same thing again and again. When you reach to the last part where you are dealing with continuous compounding, I'll explain to you what is really needed over there. But let us do one thing. Let us first understand how to write up the solution to this example. So as a part of solution to this example, start writing. Number 1, if interest is compounded annually, the future value will be the present value into 1 plus I raised to n. Because here the frequency of compounding is annual, you don't have to actually carry out any adjustment. So it will be $1,000 into 1 plus 0.219 raised to 2, and that will be simply giving you $1,485.96. Let us move ahead and take up the next calculation where interest is compounded half yearly. So this time what adjustment you need to carry out, please observe it very well. Because the interest is compounded half yearly, means the frequency of compounding within a year is 2 times. So first of all, 2 different places 2 will be adjusted. One is the stated interest rate or the stated annual rate will be divided by 2, because if this rate is applicable for the entire year, half of that rate will be applicable for half year. So I by 2 becomes the periodic rate, but because the compounding is going to happen twice in a year and number of years in our example over here is 2 years, so it will be 2 into 2. So when you put up the values, it will be 1000 into 1 plus 0.219 by 2 raised to 2 into 2. When you apply this calculation, what you effectively get is 1000 into 1 plus 0.1095 raised to 4. So it will be basically 1000 into 1.1095 raised to 4. Now over here, let me bring your financial calculator into application. So along with me, you also be ready with your financial calculators, and what I am going to do, try to understand. I am taking 0.219 divided by 2, so 0.219. 0.219 indicates 21.9%. So 21.9% or 0.219. First of all, we are dividing it by 2. When I divide it by 2, what do I get? 0.1095. Means it will be 10.95% for a period of 6 months. So 0.1095 becomes the periodic rate. This will be added to 1. So add 1 to this, we get 1.1095. Now this has to be raised to 4 times, because 2 times as frequency of compounding within 1 year and 2 years is the period mentioned in the example. You would find somewhere in the middle row, 4th switch, it will be y raised to x. To be more specific, 1, 2, 3, 4, 5. 5th row, 4th switch, it will be y raised to x. Check 5th row, 4th switch, y raised to x. So what you do is, on your screen what is appearing is 1.1095. You want to apply the power as 4 times, so press y raised to x and then press 4 and simply press equal to. So what you get is 1.5153. 1.5153 becomes the effective factor for that entire 2-year period. That when you multiply to $1,000, you get 1,515.34 maybe. That will be your final answer as the future value, 1515.34. So do one thing, please write up this whole calculation. In the coming parts of the example, I'll once again explain to you what you need to do in your calculator. Let us move ahead and now deal with the next part, where interest is compounded quarterly. So now over here, what you need to do, here you need to understand that the frequency of compounding is quarterly. So what will be the compounding frequency within a year? 4 times. So m becomes 4. So first thing what you have to do is, the stated interest rate or the stated annual rate you have to divide by 4, and 1 plus I by 4. I by 4 becomes a periodic rate. So 1 plus I by 4 raised to 4 times within a year and total period being 2 years. So it will be raised to 4 into 2, and accordingly you make the calculation. So your calculation goes this way: P into 1 plus I by 4 raised to 4n. When you substitute all these values, the stated annual rate is 21.9% or 0.219. So I take 0.219 divided by 4, I get 0.0548. To that I add 1. So I get 1 plus the periodic rate raised to, we have to take raised to m for the number of times compounding is happening within a year, which is 4, multiplied by 2 years. So it will be raised to 8. If I need to find that 1.0548 or 1.05475, whatever it is, raised to 4, I have to again use the same switch, that is y raised to x, and the power this time will be 4 into 2, that is 8. So what is appearing on my calculator screen is 1.0548. What I'll do to this is I'll press y raised to x, that is the switch, the fourth switch in the fifth row. So y raised to x 8 and then press equal to, I get 1.5318. Now on this, if I simply multiply 1000, I'll be getting the future value as 1531.7796, or you can even write it as 1531.78. So let us observe what is appearing on the screen. Yeah, 1531.78. So that will be your answer for what will happen in case of quarterly compounding. After this, whatever be the content ahead within the example, that is monthly compounding, daily compounding, I will not put up the answers directly. I'll give you a minute to make the calculation on your calculator, and then you can check the answer and then note it down. So before we proceed ahead with any of that, please write up this calculation quickly. Alright friends, once you have completed writing this much, let us move ahead and go to the next part. If interest is compounded monthly, so what will happen? As usual, you are going to consider that the frequency of compounding over here will be 12 times within a year. So I will be divided by 12 and 1 plus I by 12. So I by 12 becomes the periodic rate. So 1 plus periodic rate raised to 12 times into 2 years, correct? So how to do this, I will not guide you further. You will do it on your own. I'll give you 2 minutes time to make the calculation. Alright friends, I'm sure you would have attempted the calculation and you would have got the answer correct. Now whether your answer is correct or not, let us verify. I gave you 2 minutes time, but that much time you also would have realized isn't needed at all if you have done it in one go. But what happens many times, students doing this calculation for the first time, they may end up taking a little longer time, and therefore I have given little relaxed time of 2 minutes. What is to be done? Let me explain to you. This is my calculator. After turning on the calculator, I directly take 0.219, which is the stated annual rate. I divide it by 12 months to get monthly rate of 0.0183 or 1.83% approx. Because my calculator is set to 4 places after decimal, I cannot read anything beyond that. So it is 0.0183. This is the periodic rate. Because I have taken I by 12, to this I will add 1. So plus 1, I get 1.0183. This is the factor for one period, and there are going to be 12 into 2, 24 periods. So this has to be raised to 24. So what is appearing on my calculator screen right now is 1.0183. I press y raised to x and input 24 equal to, what I get is 1.5435. This is the factor effectively for the entire 2 years. To this I multiply the present value, that was the principal amount, $1,000, and what I get finally is 1543.498, or you can round it off to 1543.50. 1543.50. Let us check whether I have done it correct or not. So when you make this calculation and you are correct with your calculation on your calculator, in exam you don't have to write anything, your final answer should match with this 1543.50. So though in exam you don't have to write anything, but initially I am emphasizing that every example you solve, you write the calculations so that while you are revising with your notebook and a calculator in hand. That time you don't have to write anything, you just have to take the flow on your calculator. That is how you are going to revise and practice. But right now, if you don't write this, you will just forget what you have learned step by step, and it will create a big mess in your revision and practice. So write up this whole thing and then I take you ahead. Let us move to the next part, where interest is to be compounded daily. Now, just as a small hint, I will say I will be divided by 365 and it will be raised to the total number of periods, because interest is going to get compounded daily. Within a year, it will be 365 times that the compounding will happen, and there are 2 years. So 365n means 365 multiplied by 2. Please check whether you are correct with the calculations or not. So it will be basically 1 plus 0.0006 raised to 730. So 1.0006 raised to 730 would give you the factor. Now to do this on your financial calculator, it is no big deal. What I do is 0.219 divided by 365. And I get 0.0006. To this I add 1. So the periodic factor, that is factor for 1 day, becomes 1.0006. This I have to apply the power of 730. So again, when it is 1.0006, press y raised to x, then input 730 and equal to, what you get is 1.5494 multiplied by 1000, and you get 1549.40 as your final answer. 1549.40. So that's your final answer over here. So in case you have not written the calculations yet, let us move ahead and take up the last part. Now this is not something that you need to try. I will explain it to you how to make the calculation. If interest is compounded continuously, so what could be the shortest span of time? Every moment, not even a second, even a fraction of second. So when interest is getting compounded in that kind of frequency, you cannot use the usual manner of calculation. So we have to use some mathematical tools over here to apply something called as continuous compounding. The approach for continuous compounding for computing the future value is f equals to p multiplied by e raised to r into t. R is that stated annual rate. Here we are not calling that as I but R, because just the nomenclature is like that. It is the variable generally in that style we state. So e raised to r into t, t stands for the time period, which is 2 years in our case. So time period in years we have to state. So if it was 2 months, you will not write t as 2 but 2 by 12. If it is 6 months, you will write it as 6 by 12. 1 month you will write by taking that as 1 by 12. If it is 15 days, you will take 15 by 365. But our time period over here is 2 years, so t will be 2. R will be 21.9%, that is 0.219. But this 0.219 multiplied by 2 becomes the power of e. So what you need to do is 1000 into e to the power 2 into 0.219. So 2 into 0.219 will become 0.438. Pick your calculator, I'll explain you how to do that. So when you turn on your calculator, make sure everything is all clear. You start with 0.219, which is the stated annual rate. Multiply this by 2 years, that into 2. What you get is 0.438. Now this should become the power of E. Now on your calculator, you need to find again the 6th row this time. 6th row, first button, 6th row, first switch is ln, that stands for log normal. It is the natural logarithm. What is natural logarithm? If you don't know, don't worry about it. We don't need to know it right now. We'll learn it in a while later. But I'm interested what is written on top of that button, ln. So I'm talking about 6th row, first switch, ln. On top of that you will find e raised to x written. So what you need to do, e raised to x, whatever is appearing on the calculator screen, that you have to consider as x, and you want e raised to x. But e raised to x is not the main switch, it is on top written like that. So you have to use the second function. So when 0.438 is already there on your calculator screen, press second and then press ln. So actually it will not be ln that gets activated, it will be e raised to x. And what you get is the factor 1.5496. So when $1,000 getting multiplied to 1.5496, your result will be the future value equals to $1,549.60. So I'm sure you have understood what is to be done on your financial calculator and what is to be written over here. And later on, so many times we are going to apply this continuous compounding that you will get this thing tuned into your practice. So don't worry if you haven't got that confidence in one go. Confidence won't come just like that. Gradually we are going to practice this a lot many times. So first thing what I want you all to do is write up this entire calculation. Let us move ahead and take up the next example. It says compute EAR. We know one thing, that EAR stands for effective annual rate. If the stated annual rate is 12% compounded quarterly. Now let me explain this to you. How would you do this calculation? The questions ahead, all the questions I am not going to solve for you. You will have to try it out on your own. Over here I am definitely giving you some guidance. Let us read the example once again. It says compute EAR, that is effective annual rate, if the stated annual rate is 12% compounded quarterly. So first what you do is pick your calculator, turn it on, and 0.12, that is 0.12 is the input. This is the stated annual rate. Compounding frequency is quarterly, means it is 4 times in a year. So m equals to 4. So 0.12 divided by 4, it becomes 0.03. If it is 0.03, this is the periodic rate. To this I will add 1, and now I want the power of this to be 4 times, correct? So what I'll do is, this I have to raise to 4. So 5th row, 4th switch, it is what? Y raised to x. So press y raised to x, then press 4 and equal to, what you get is 1.1255. Now 1.1255 is the factor for the effective period of 1 year where the compounding happened 4 times. But this is still a factor. You need to know the effective annual rate. From the factor you subtract 1 to arrive at the interest rate, that is 0.1255. If you want to convert that into percentage, multiply by 100, it will be 12.55% as your final answer. So how to write up that entire calculation? Just observe. Here m equals to 4. So the periodic rate is 12 by 4, that is 3%. So factor will be 1 plus periodic rate raised to m, and to compute the effective annual rate you need to subtract 1. And as I have explained to you, once you take this factor for the period, that is 1.03, that is 1 plus 0.03, this is the factor for the period, raised to 4. How to apply that raised to 4? And from that you have to subtract 1 to arrive at the effective annual rate. Let us move on to the next one. It says compute EAR if the stated annual rate is 18% compounded monthly. And let us see what will be the correct answer over here. The correct answer as periodic rate will be 1.5% or 0.015. So the effective annual rate will be 1 plus periodic rate raised to m minus 1. When you apply that calculation, what you get is 19.56% as your effective annual rate. Take up the next example. Using a stated rate of 6%, compute EARs for semi-annual, quarterly, monthly and daily compounding. Now you have 4 different compoundings stated over here: semi-annual, quarterly, monthly and daily. Let us check whether you are correct with all of these. So when it comes to semi-annual compounding, what you are going to do, you are going to report the answer as 6.09%. If it is quarterly compounding, you are going to report your answer as 6.136%. If it is monthly compounding, you are going to report your answer as 6.168%. And if it is daily compounding, you know how to do it, and your result will be 6.183%. Let us move ahead and take up the next example, example 27. It says John plans to invest $2,500 in an account that will earn 8% per year with quarterly compounding. How much will be in the account at the end of 2 years? Now, this is again an example that I would want you to attempt on your own, and I hope that your calculation will be correct. So your periodic rate over here will be 2%. So it will be 2,500 into 1.02 raised to 8. So your answer goes to $2,929.15. Alternatively, you could have computed the effective annual rate first, and then you would have applied that on 2,500 to compute the same result. Let us move ahead and take up the next example. That will be example 28. Alice would like to have $5,000 saved in an account at the end of 3 years. If the return on account is 9% per year with monthly compounding, how much must Alice deposit today in order to reach her savings goal in 3 years? Now, first of all, in this example, what is different? The targeted future value is given to you as $5,000. So the present value or the amount that you should invest now, that is missing. So in your calculation, F is given and P is missing. I don't think there is much of a problem for you to compute this. The real logic that you need to apply is of the effective annual rate or through compounding and finding the present value through the given amount of future value. You have to do it correctly. That is your challenge. And here, I am not going to solve it for you. You have to do it. So let us check whether you got it correct or not. So the effective monthly rate will be 9 divided by 12. That will be 0.75%. So on absolute basis, it will be 0.0075. So when you are applying the factor based calculation, it will be 5,000 divided by 1.0075 raised to 36, because there will be 36 months in these 3 year span. So the final answer comes to $3,820.74. Alternatively, you can first compute the effective annual rate in the manner that you have learnt, and then you apply the effective annual rate on $5,000 because you want to find the present value, correct? So it's not the calculation of computing the future value from the present value. You have to compute the present value from the future value. So you need to take 5,000 divided by 1.093807 raised to 3, because this precisely becomes your effective annual rate, and because the period is 3 years, it will be compounding 3 times. So keep in mind one thing, if you are making the direct calculation, it will be directly done this way. If you are making the calculation through EAR, you will have to do it this way. Eventually you get your answer as $3820.74. Now sometimes in your exam you may face questions where you might have to compute EAR as well as the present value. In that case, if both have to be calculated, you have to follow the second alternative. If you have to just calculate the present value, then first alternative is more direct and quicker. So in case you want to write down the whole thing, you just write down this entire thing, and with that we will be putting an end to this particular session.